The change in number of moles when the pressure changes?
No.
The total pressure equals submission of pressure.
The sum of the pressure, the total pressure is the sum of the partial pressures.
One way to put it is to say that it is actually P total equal to what? It's the total pressure of each component. P total is the pressure of each component by itself. Clear? Or P total equal to what? Summation of Pi. What's this? How do you read this?
Sigma.
Sigma of Pi. What's sigma of Pi?
The sum.
Actually, Pi, this one is exactly like this one. It's the summation of all the components. All right. Then we have another definition. What is this letter?
Molar fraction.
Yes, you have to know this. It's mole fraction. What do you mean by mole fraction?
The ratio between moles.
Moles of I or A divided by number of moles of what? A plus number of moles of B.
Total.
Oh, I didn't know. All right. Total, but we cannot say total because each one we have to come to calculate ourselves. Number of C and so on. That's called mole fraction. If you know mole fraction, what is the Dalton law then? What's Dalton law? The other way to write Dalton law is to say PA is equal to what?
Mole fraction.
XA
Times
Fraction times P total.
P total. All of these is ways to say Dalton law. This is Dalton law, and this is definitely Dalton law. All right. What's the value of the mole fraction?
less than 1.
What? What's
Less than 1.
when we say fraction, what's the meaning of fraction?
Percent.
Integer over integer.
What again?
It's always less than 1.
Yes, that's exactly the meaning. Fraction means, just the word fraction means less than 1. You have to be careful. What will be the total mole fraction of XA plus XB plus XC if we have only 3 components? What will be the total mole fraction?
1.
Exactly 1. You have to be careful with this. So the mole fraction is less than 1, and if you add the mole fraction of all the components, the total must be 1. Is this clear? Good. Next, let's solve this problem very quickly. We said that here we have a vessel, 1 liter vessel contain 0.215 mole into gas and 0.0118 mole H2 gas. What will be the pressure of which one? Determine the partial pressure of the component and the total pressure of the vessel. What will be, just let's do it one by one. What will be the pressure of hydrogen, H2 gas only? Use one of these. Which one you're going to use? First one or the second? This is number 1 and this is number 2. Which one you're going to use? The first one. Use the second equation. Use this one to solve this problem. What's the pressure of H2 then?
We need to get the molar fraction first.
Okay, find it. What is it?
It will be
0.0118 divided by what?
0.018 plus 0.15.
plus 0.011.
Yes, that's, don't forget this now, 118. All right, what will be, so times what? P total. Times P total. All right, good. Now, of course, we cannot solve this problem till now because we don't know what's P total. Same thing with P nitrogen. P N2 is equal to what?
0.215.
0.215 over the sum.
Times P total. Good. Now, let's go now and calculate. What's P total? Can we calculate P total right away?
Yes, with the perfect gas law.
Which is what?
Ideal gas.
Ideal gas law. What's P total? Equal to nRT and T RT divided by V. Okay, what's NT?
The total number of moles.
What?
Total number of moles.
Exactly. Give me a number, which is exactly this number.
0.4742.
No, it cannot be. Wrong.
0.2268.
Yes, 0.2268. Okay. R, what's T?
$198.65.
165, yes, 45.65. Okay, and what's the volume?
1 liter.
1 liter.
Give me an answer now. Of course, R is what? Well, everybody knows R, right?
Yes.
5.56, the answer.
Go ahead. Give me the P total.
5.56.
1.
56.
5.56 atmosphere. Who got the same answer?
I got it.
Yes. Right.
Then the pressure of hydrogen. Yes?
1.970.
No? It's wrong.
0.29.
0.289 actually. Yes.
0.289.
As I said, take this pressure, multiply by this fraction, and you will have the answer. Okay, what's the pressure of nitrogen?
5.271.
5.271 exactly, atmosphere. Okay, what's P total from this P total? Yeah. Now what's P total? It's equal to pressure of hydrogen plus pressure of nitrogen. We have this one and this one. We already calculated, but we want to recheck it. Add these two numbers together.
5.56.
5.6.
Is this clear? How easy?
So easy.
Two, you have to know how to deal with Dalton law. Good. Good. Okay, calculate the mole fraction of NO in 10-liter gas cylinder at room temperature that contain 6.022 mole N2 and in which the total pressure is 114.57. So you have the total pressure PT. This is PT, okay, and you have the room temperature. You have the of volume. So this is the volume. This is T, and this is PT. What can you calculate?
N.
Which N?
Total.
Yes. NT is equal to what?
PT multiplied by V over RT.
V over RT.
Exactly. All right. Which is what? 14.75 times 10
10.
divided by 0.0821 times
298.15.
298.15. Okay. Give me an answer.
6.029.
6.029. Okay. What's the number of moles of N2 only? It's given to you. What is it?
6.022.
0.02.
0.022 mole. Good. Then automatically, what's the number of moles of H2?
The difference.
The
H2?
difference between them.
Subtract the total by the nitrogen.
Not H2, but more NO. Yes. Okay, so how can you find the number of moles of NO? 6.029 minus,
0.022.
which is equal to what?
0.007.
0.007. Good, mole. Good. Then what's the mole fraction of NO?
0.007 over 6.029.
Exactly, with 1.029. And give me an answer.
1.16 times 10 to the power minus 3.
So it's 0.001.
Yeah.
All right. So what will be the mole fraction of N2?
1 minus 0, 0.
Which is
Yes.
equal to what? 9.999. Is this clear? Any question?
Isn't it 0.99?
What again?
0.9.
0.99.
It cannot be more than one. Oh, okay. I am making mistakes. I always make mistakes. Yes, of course. It cannot be more than one. If you put it more than one, you're wrong without even reading anything about the problem. So yes, it should be 0.999. Is this clear? Any question?
Doctor,
Yes.
we we should have oxygen only, right? Not NO,
Why?
because we have separated the N alone.
No, this is nothing to do. This is like putting two gases in a container. One of them, I'll put it as X, which represent the N2, and the other one, I'll put it as small o or dark like this. This is the NO gas. So we're just mixing. There is no reaction, no nothing. It's just two gases here.
Okay, I get it. Thank you.
Okay. Good. Next, we always collect gas over water like this. We make experiment like this, and in this case, we will do, if we do this experiment, we are reacting KClO3 to make KCl plus O3. So what gas we are making?
Oxygen.
Oxygen.
If you are heating this compound, KClO3 is here now. We're heating it with this flame, and you will produce what?
Oxygen.
Oxygen gas. The oxygen gas will come through this pipe, and it will come out like this. So these dots are actually oxygen gas coming out, and so this is mainly oxygen gas. Clear? And this way we collect the gas over water. Now, the water, always, if there is water, there will be also some water vapor there with the oxygen or the H2O gas available with the oxygen. Why? We have the oxygen from the reaction, right? From where did we get the water then?
From the container.
From the water itself. The water will give you some vapor, right? Okay. So the P total is actually the pressure of O2 plus the pressure of vapor, H2O. This vapor is coming from where? From the water itself, from the container, because this water will give you some vapor here. Is this clear? Always, when you do experiment in which you collect gas over water, there will be in the container both the gas that you're collecting and water. Clear? Now, the pressure of water, which is this one, depends only on temperature. And this pressure, we can have it in table. Don't memorize anything in this table, but you can see what will be the P of H2O at any temperature. So if I ask you at 30 degree C, what's the pressure of H2O?
31.8.
31.8 millimeter Hg. All right, so we know what will be the pressure of the other gas. Is this clear? So you don't memorize anything in this table, but always whenever you have you're collecting gas over of water, there will be the gas and there will be some water. Always, to know what's the pressure of water, go to this table, find what's the table from this table. Now, what's the unit that we have here?
Torr.
What's torr?
Millimeter Hg.
It's the same as millimeter Hg. How can you convert it to atmosphere?
By dividing it
760.
31.8 divided by what?
760.
Make it atmosphere. Is this clear? Is this clear? Good. Let's solve this problem. Calcium metal. So calcium metal react with water to produce hydrogen gas. Again, We're reacting this with water and we are producing hydrogen gas. Of course, there will be some water with the gas. Determine the mass of H2 produced at 25 degrees C and 0.967 atmosphere. What's this pressure here?
The total pressure.
Total pressure. What will be the pressure of H2O? What should you do? You should look at the temperature. And what should you do next?
Go to the table.
Go to the table and find the number. What is it?
23.8.
3.8. So I'll write here 23.8. What?
Divide by 760.
Can I change it to atmosphere?
Yes, by dividing by 70.
60 to make it atmosphere. Good. Then automatically tell me what's the pressure of hydrogen only.
.936.
I want more than one to do it.
It's correct. Yes.
Okay, good. Should be actually, you subtract this number, the P total, from this answer here, whatever it is. So it is 0.9 what?
36.
36 atmosphere. Okay, very good. Then automatically, what is the N for H2?
PV divided by RT.
Exactly. Give me an answer. You have the pressure of hydrogen. You have the temperature, and you have the volume. Where is the volume?
The 2
Oh.
point
This is the volume. Don't forget to change it to what?
2 liter.
Liter. And the
2.01.
Kelvin. What again?
2.01 times 10 to the power minus 2.
Minus 2. Very good. Anybody else got the same answer?
Yes. 0.02.
0.02 or 2.01 times 10 to the power minus 2. Minus 2. Good. All right. Can you change this to how many grams H2?
Multiply by the molar mass.
Yes.
No, not divide. Multiply by the molar mass of H2.
.04.
0.04. Who else got the same answer?
Yes, I
Yes,
got it.
I got it.
All what we need to do is the number of total number of moles multiplied by 2 times 1.008. Why did I write 2 here?
Because it's H2.
And why? What's 1.008?
Molar mass of
Molar mass.
hydrogen.
Atom. Exactly. Any question? Good. Let's move. All right. Now we're going to do some other facts, and now we're going to talk about molecular speed. Molecular speed, and I'm going to define 2 things. I'll define it later, which is diffusion and effusion. 2 words. I want you to write them now and memorize them, but we will explain them when we come to them. Diffusion and effusion. Diffusion and effusion. Okay, good. We're going to talk about the theory. This theory is called kinetic molecular theory of gas. What's the meaning of kinetic?
Motion.
Yes.
Relative to
It's
motion.
to what?
Motion.
Related to motion. So, what are you going to calculate if it's related to motion?
Energy.
Energy and speed.
Speed.
Speed. So, we're going to use U for speed. U for speed. Okay. Everybody knows that the kinetic energy equal to what?
Half
mv square.
Times v
M
squared.
U square. We're going to use U here. All right? Good. So U is the speed. Very good. Okay. And what's the unit that we usually use for energy?
Joule.
Joule.
Joule. Very good. What's the unit we use for speed?
meter per second.
Meter per second.
And the mass?
Kilogram.
Kilogram. Now, the first thing I want you to do, I want you to find what's the kinetic energy of O2 molecule. No, not yet. Yes. Just a second. I just want to say one thing before I go further. Don't forget, this one is for what? One molecule. This is for one molecule. If I want it for mole, what should I do?
Divide by
Times
Avogadro.
Avogadro.
If I want it for mole, I must multiply it by Avogadro's number. So it will be N, which is Avogadro's number, Na. Don't forget, write this Na, which is what? What's Na?
Avogadro number.
Multiply by half mu squared. Keep this in mind. Okay, is this clear?
Doctor, why do we multiply? Why don't we divide?
If it's one molecule, this is what you have. You want it for, if this is the one for one molecule, if you want it for two molecules, what should you do to calculate the kinetic of two molecules?
Multiply by 2.
Very good. If you want Avogadro's number of molecules, which is 6.02 times 10 to the power 23, you multiply or divide?
Okay, thank you.
Okay, good. Very good. Next. All right. I'll keep this in mind. We're going to discuss things now. The gas is these are the kinetic theory. It says that the gas is available in a container if the volume of the container is the actually volume of the space. We consider the kinetic theory, consider that the volume of molecules is negligible. What's the meaning of negligible?
Not noticed.
We don't care about it.
It's considered to be zero. Considered to be zero. So in this container, the volume represents the volume of the container. What's the volume of the molecules in this container?
We don't take it into account.
It's considered to be zero. That's the kinetic. Gas molecules are in random motion. What's the meaning of random motion?
عشوائي حركة عشوائية.
And they move in straight lines, colliding with the wall of the container, and that's what these collision are perfect. This means perfectly elastic. What's the meaning of perfectly elastic?
Doesn't lose energy.
This means, of course, this means if this is the container again, and the molecules are coming here and hitting the wall, of course, what will happen to the molecule? It will go to the other side. This molecule hit the wall, and another molecule comes this way and hit the wall and go in a straight line, then go this way. Okay. This hitting of the wall is what's causing the pressure. Pressure is the collision with the wall. All right, and this collision is perfectly elastic. What's the meaning of elastic?
مرن.
مرن.
What's the meaning scientifically of marine?
It doesn't lose energy, but
There is
just the
no
transfer.
energy. There is no loss of energy. All right, and that's very important, because if there is any loss of energy, the container will heat very, very quickly. I mean, it will be thousands of temperatures higher than if there is any loss of energy. And that's why there is no, the meaning of perfectly elastic, no loss of energy. Okay? There is no attractive or repulsive forces between the molecules. What does that mean? If we are in the container again, and this is one of the gases and this is the other gases, they don't see each other or they don't feel each other at all. There is nothing between them. They don't attract or repel each other. Each one is by itself. It doesn't care about the other gas. There is no, they don't have any attractive or repulsive forces between them. Clear? Next, energy is also, I want you to memorize this equation very, very well. Energy is equal to 3, or sorry, energy is proportional to T. Energy is proportional to T. This T actually, or I will give you right from this equation, this energy, I want to write this now, is equal to 3 over 2 R times T. So the constant is 3R over 2. Is this clear?
Why, Doctor?
I'm telling you, it's not why. This is the constant. As I said, the energy is related to heat. If you increase the temperature of the gas, what will happen to the energy?
Increase.
Increase. So as you increase this one, you are going to increase this one. The proportionality constant, I'm giving it to you. Don't try to derive it. It's 3R over 2. Clear?
Okay.
Just memorize it. I want you to memorize this equation like when you memorize this equation.
Mr.
Yes?
R is the same as the ideal gas?
Yes, exactly. It's the ideal gas constant. Good question. Okay, what speed we're talking about? We're going to talk about a speed called mean square speed. I want you to memorize the name, mean square speed. And usually we write under here MS. Root v squared, yeah. RMS, yes. Root v squared, R. So the speed that we're going to talk about is when we take the, so U R N S. So I want you to tell me what are we doing here? What's this U square average? Is equal to what?
The speed of the atoms.
The average speed of the whole molecules.
Of the whole, I mean the speed of each molecule divided by the square first. The square, that's why it's the mean square speed. We take the speed, the square of each unit and divide by n. And then I want to take the square root of this one, U2 square. This speed, I'm going to call it URMS. That's what we're going to use in this equation, URMS. Is this clear? Now, I want you to tell me, as I said, this energy is for how many molecules?
One molecule.
One. Can we make it for a mole? So this speed is per molecule. Can we make it per mole?
Multiply by Avogadro.
N times half mu square, all right? And this way, this will be in per mole. Clear? Good.
Yes.
Now, don't forget what's Na.
Avogadro number.
Avogadro's number. Okay, good. And this is half mu squared. If you multiply Avogadro's number by m, what are you going to get?
Molar mass.
Exactly, molar mass, but in what unit? What?
Kilogram per mole.
No, you'll get it by gram. Well, how do you find the mass of anything? I mean the number of moles of anything. N for any gas, what is it equal to? N.
Mass over molar mass.
Mass over molar mass, right? Good. Okay, if I want to calculate the molar mass, sorry, I probably, let me take it the other way. Okay, that's not important. I know also, I told you this many times, 1 gram is equal to what? AMU. What's AMU?
Atomic mass.
Avogadro's number.
What's AMU? What's the meaning of AMU?
Atomic mass unit.
Atomic mass unit.
What's the relation between 1 gram and AMU?
1/12.
Avogadro's number.
Avogadro's number. Just simply say 6.022 times 10 to the power what?
Minus 23.
23.
No, plus 23. Right? Good. All right. So if the unit for any gas, let's say the gas is hydrogen. What's the mass of hydrogen? Gas. H2. H2 gas. 2.016 AMU. This is for 1 molecule. What's the mass for in gram?
Same thing.
No.
Multiply by Avogadro's number.
No, no, I want not 1 mole. What's the mass? Okay, this is 1 gas molecule. Well, if I have 1 mole, what is it equal to?
Same in gram.
Yes, it's exactly the same. Exactly the same. 2.016, but now I use 1 gram. What did I do? I multiply it by Avogadro's number to change it to gram. That's exactly what I did here. I multiply by N, which is Avogadro's number, by this mass, and this will give us the unit in gram. I hope this is clear.
Doctor, how did you get 2.016?
The first one or the second one?
The first one, AMU.
Tell me, how do you get it? You should tell me. From where you get it? From the periodic table. You have a periodic table.
Yeah.
Tell me why. What? It's 2.
So it multiplies by 2. Okay.
Is that clear?
Yeah.
Okay, good. Now, if I have 1 mole of the gas, what will be the mass? Same number, but in gram. What did I do? I multiply this AMU by Avogadro's number and change it to gram. So if I multiply the mass for 1 molecule by Avogadro's number, then it will be changed to gram. In this way, I want you to relate 1 and 2. If we are talking about the same gas, E1 equal to E2. So what will be the relation in this case? Three over 2 RT equal to what?
A multiplied by
half mu squared.
1/2
half m
over times what? Molar mass, because I combine this one with this one to make it molar mass, times what?
U squared.
U squared RMS. Exactly. Now, R is in what unit? We should use R in here for energy. So which R we're going to use for energy?
8.314.
Let's go back to the R in the beginning of the course, of the chapter, I mean. Which R should we use?
8.314.
8.314 joule. Why did you choose this one? Because it's in joule, and we're talking about energy. That's why I told you this R and this R are very important. The rest are not important, don't worry about them. But this one, you don't have to memorize any of them. They are available, but you should know which one you should use. Is this clear? So we're going to use from now 8.314 in energy. Good? Okay, now. Okay, now let me ask you another question, very important question, which is, what's the unit for energy? The SI unit for energy?
Joule.
Joule.
Okay, what's the unit for mass in SI unit?
Kilogram.
Kilogram. And that's why if I give you any gas, you should, in this M here, you should put the mass in kilogram, not in gram. So what's the mass of H2 gas? 1 mole of H2 gas. What's the mass of H2 gas? If I want to use SI unit, it will be again 2.016, what?
Multiply by 2.
Times 10 to the minus
10 to
3.
power minus 3.
Kilogram. Exactly. Very good. Next, the 2 will go with the 2. I want you to tell me, to derive to me now, what's U, R, M, S? What is it equal to?
Square root of 3 RT over molar mass.
3 RT over what?
Molar mass in kilogram.
Yes. Kilogram, very important. Kilogram.
Doctor, what
Clear?
does this mean?
Memorize this. What again?
What does RMS mean?
Root, mean square. See, this speed is called mean square. And if you take the root of it, it will be root, this is the root, right? Mean square, which is the mean square is the average speed, square divided by the number of molecules. And then if you take the square of it, it will be root mean square. You have to know the idea here only. We're not going to calculate it for molecules. Any question? You have to memorize this equation extremely well. Is this clear? Good. Now, the gases are comparable. Compressible. What's the meaning of compressible?
Can be compressed.
Can be less volume. You decrease the volume. What will happen if you compress it? What will happen if you decrease the volume? The pressure will increase.
Pressure will increase.
Why? Because the molecules are now hitting the wall more. The distance is small, so the molecule, if it's here compared to here, okay, we said what's the pressure? Hitting the wall. And then it will go to the other side to the wall here. And then it will go this way and hit the wall. Come this way, hit the wall. What will happen if we make the volume smaller?
Hit the wall more.
And what will happen to the pressure?
More
Increase.
Increase.
That's Boyle's law. So we can explain Boyle's law this way. Good. How about temperature? Charles' law. What will happen if you have same container? We have this T1 is 25 and T2 is 50. Which one will have more pressure? It's the same volume. Which one will have more pressure?
50 degrees.
Huh?
50.
The one with 50. Why? Explain it from kinetic motion.
It will be speeder.
It will be more speed, more velocity, and as a result, it will hit more very quickly, more than this slow one. Is this clear? Good. Okay. And Dalton pressure. Okay. Why we think Dalton pressure is applicable in the Dalton law? We said that if you have a container here and you have only X gas, it will have certain pressure, P1. How about if we have O gas? Oh, that's not, I will put it as like this. It will have P2, okay? If we mix them together and put the dark one, the balls here, what will be the total pressure? P1 plus P2. Explain it from the kinetic theory. Why this one is true? Because we said that no molecule is feeling the other. Each molecule is feeling that there is no other gas. And that's why they will have exactly the same pressure, regardless if there is these poles or not available. Because all the molecules don't feel each other. I hope this is clear. And that's the root mean square speed. We just derive it. You must memorize it and memorize it extremely well. Don't forget one thing only, which R you're going to use.
8.3.
8.34, the one with joule per mole Kelvin. Good. And the mass, what are you going to do with the mass?
Kilogram.
In kilogram. Not in gram, but in kilogram. Don't forget this. Good. What will happen if we increase the temperature of the gas?
Increase the speed.
Increase the speed. Exactly. That's table here. See, it's for the same gas, which is N2 gas. What will happen to the average speed? This is the average speed. This is the average speed. This is the average speed. Why did it increase?
Because the temperature
increased, right? Good. What will happen? Which is faster, Cl2 gas or N2 gas?
N2.
Why?
Because it has less
Less what? Molar what?
mass.
Molar
Lighter.
mass. Less molar mass. And that's exactly which of these gases is the fastest. Is it helium or nitrogen or chlorine?
Helium.
Helium is the most speedy because of this average. Clear? Very good.
Doctor, can you repeat that, please?
In
The change in variables?
yeah, which one is going faster, Cl2 gas or N2 gas?
Well, we said N2 since it has less molar mass.
Not, we said, I mean, depending on what? If it's the same temperature, of course. M is here. If you increase M, what will happen to the speed?
Decrease.
Very good. So this one is 71 and this one is 28. Which one then it will have greater speed? The 71 or the 28?
28.
Exactly. Is this clear?
Yeah.
Now, if you divide RMS1 over RMS2, this will give you the relation, because if it's the same temperature, these will be to go with each other, and we will have, listen here very carefully, this is 1 and this is 2. What will happen to the M1 and M2? M2 over M1. Is this clear? You have to memorize this equation as well, or derive it from, this is M1 and M2. Clear? Good. Determine how much faster helium atom moves on average than carbon dioxide. Which one is faster? Helium? He or CO2?
Helium.
Helium.
Why?
Less molar mass.
Lighter.
What's the volume of helium atom? Okay. What's the volume of CO2?
Do you mean the molar mass?
Yeah, of course.
44.01.
Exactly, and this is the mass of helium. Next, what will be the speed of helium over the speed of nitrogen or CO2? Now, before we do any work, the answer, look at the what I wrote. Is the answer should be greater than 1 or less than 1?
Greater than 1.
Greater than.
Greater. Greater than 1.
Come on. What do you think? Greater than 1 or less than 1?
Greater.
Greater than 1.
Greater than 1.
Why greater? Because the speed
Because
of...
the speed of helium is greater than the speed of
Exactly.
CO2.
So the answer should be greater than 1. Now, do the calculation. Square root of what now?
CO2, the molar mass of CO2 over molar mass of H2.
Exactly, reverse it now. Molar mass of what?
H2.
Okay. Now, which unit should I use? Should I use gram or kilogram or what?
Kilogram.
Kilogram.
Doesn't make difference.
I don't. Even if you put AMU as is, AMU, fine, what will happen?
It will give the same.
The unit will cancel.
So in this case, don't worry about the unit when you are comparing, when you're taking relativity. But if you are calculating speed, then you have to be careful. Good. Next, what's the answer? I need an answer. It's the square root of what?
44.01.
44.01 divided by 4.003. Give me
To
final.
be 3.32.
Should be like this. Good.
Yes.
Very good. So let's do it the other way. What will be, I have another question now for you, very quickly now. What's the speed of helium gas, or let's give another example. This is here. This. Okay. This away. There is another question now. It's not the same question. What's the speed of CO gas at 25 degrees C? What's the speed of CO2 gas at 25 degrees C? This is not part of this question. What's the answer? What are you going to do? Which law you're going to use? You what?
Equal root 3 RT over molar mass.
Equal to the root of 3 RT over molar mass. Exactly. So square root of 3 times 8.314 times what? 298.15 divided by, what should I have?
Molar mass in kilogram.
Go to your periodic table and give me whatever you want to tell me.
16 plus 12.01 divided by 1000.
No. 28.01. What's 28.01?
Should be in kilogram.
Yeah, I did not finish it. But what's 28.01?
AMU.
12.01 plus 16. Right? The mass is from the periodic table. That's 28.01. Now I multiply it by minus 3. Why did I multiply it by minus 3?
Kilogram.
To convert it to kilograms.
Kilogram. Not in gram, but in kilogram. Now give me the answer.
$515.26.
0.26.
What's the unit?
meter per second.
Exactly, meter per second. Don't forget this. So how should you do with this problem? You just take the speed, the mass of the molecule from the periodic table, which is the addition of whatever available in the periodic table, and multiply it by 10 to the minus 3 and make it in kilogram. That's it, as simple as that. Is this clear? Okay. The diffusion, if you have two gases like this, Okay, can you see? There is a purple gas here and yellow gas here. What will happen if you open this valve?
They will mix.
They will mix. That's what you did. You open the gas and they will mix like this. This is called diffusion. Clear? Good. Effusion. What's the meaning of effusion? If you have all the gas in one chamber, all the yellow gases here, and you have vacuum here, vacuum on this side, and you make this small opening here, what will happen to the gas?
Go from the left to the right.
Escape to the other.
Gas to the vacuum, it will start going like this. So these gases come from here actually. This is called effusion. That's the meaning of effusion, and that's the meaning of diffusion. I hope it's clear and you can read them very easily. As I said, very important relation between the names, diffusion and effusion. That's the definition of diffusion. That's the definition of effusion. Let me ask you a very simple question. If you have H2 gas and Cl2 gas, which one will effuse faster?
The one with
They are in the same temperature, H2.
Of course, the same temperature, yes. Why are you saying H2?
Because it's faster.
More speed.
Because the fusion and diffusion depend on what?
Speed.
Speed. And since this one has more speed, it will effuse faster. How about the time? Which one will take more time to effuse?
Cl2.
What?
Cl2.
Cl2 will take more time. This one will effuse faster, but this one will take more time. Very good. Now, this effusion or diffusion is proportional to mass. If we are at the same temperature, same T, then the rate is 1 over m, or rate of effusion of 1 divided by rate of effusion of 2 equal to what?
M2 over M1.
Square root of M2 over M1. Did we see this before?
The same as speed.
Exactly, because it's related to speed. So speed of 1 divided by speed of 2 is equal to rate of effusion of 1 over rate of effusion 2 equal to square root of mass 2 over mass 1. You have to keep this in mind and make the relation very easy. Is this clear? Okay.
Yes.
And with the ideal gas, then we're going to another gas. This gas now is called real gas. So we're done with the ideal gas. We're not dealing with ideal behavior now. We're going to go to real gas. What will happen? Ideal gas is when the molecules don't feel each other at all. If there is high, very high pressure, P, very high, and if there is very low temperature, T, very low, then the gas will change from ideal to real. If you increase the pressure a lot or decrease the temperature a lot, then it will change from ideal to real. Why? Because if the pressure is high, this means they will be close to each other. The molecules will be close to each other, and we said that, if you remember, we said in the beginning that in the ideal gas law, if you remember, we said that each gas don't feel the other gas at all, as if it's not existing. We even said this. See, we said that each, look at the gas here, you can see there is small dot, but they don't feel each other. They don't attract or repel or do anything with each other. Why? Because they're very, very far from each other, and the pressure is, because what will happen if you increase the pressure a lot?
It will be near from each other, closer.
Be very close to each other, and as a result, they will repel and attract each other, and this will change the pressure. Now, if this is hitting the wall, in the let me ask you a very quick question. I want you to tell me the pressure of the red ball here. Red ball. If it is ideal compared to real pressure of real gas for red ball also, which one will be higher pressure, the ideal or the real?
Real.
No, the pressure will be higher for ideal. Why? Because here, in the real gas, the other molecules are preventing it from hitting the wall. So the force of hitting the wall will be less. In the ideal gas, if this is the ideal gas, this red ball is not feeling the other molecules at all. So it will hit it with a certain pressure. Clear? But here, is it going to hit with the same pressure? Yes or no?
No.
If this one is P1, let's say, what will be the pressure of this one? Less than P1. Tell me why.
Because other molecules fall off it.
The other molecules is holding it. تخيل انت لو تروح وبتصدم في جدار واثنين ماسكينك من الخلف، ما حتقدر تصدم بنفس القوة لأن اثنين ماسكينك مثلا. All right, is this clear? Okay.
Yes.
Don't worry about this. I want you to know only one thing from this whole concept. I want you to know this is what's called the van der Waal equation, or the real gas equation. And I want you simply to memorize it. And I'm not going to explain much for you other than, look at this one. It's PV equal to nRT. Did you see this equation before? PV
Ideal gas law.
nRT. But what did we do? We made some changes. And this, then again, what's N?
Number of moles.
Number of moles. What's V?
Volume.
What is V here?
Volume.
Also volume.
What's N?
Number of moles.
Okay. The other things that you don't know is A and B. This is available in tables. Don't memorize anything. But if I give you the question like this, I will give you these constants. This is A and B for different gases. A and B for different gases. But don't worry about it at all. This is, if I'm going to give it to you, I will give you this table. Otherwise, you don't have to calculate it. Okay, very quickly, before we stop, I'm not going to even explain this equation. I want you to solve it at home. If we have NH3 gas, don't worry. As I said, if it's NH3 gas, what's A and B? You take it from here. Okay? Then I want you to apply the pressure, calculate the pressure of the gas for ideal gas and for real gas. Let's start with ideal gas. We know that the pressure is equal to what?
nRT over V.
nRT over
V.
V. What is N?
3.5.
Okay. What's R?
0.081.
Yes, 0.0821. Don't use the other R. Okay. What's T?
320.15.
320.15. All of this divide by what volume?
5.2.
5.2 liter. Find the pressure.
17.69.
17.7 atmosphere actually. This is for ideal. I want you now to calculate P for real gas. And I will give you this as a homework. I mean, do it at home. All right? Go to this equation and apply it in your calculation. You have everything here. You have the pressure. This is the pressure of the real gas. This is the pressure of real. That's so you're going to calculate this pressure. You have the A, you have N, you have V, you have V, and you have N in here, and then NRT. So this is like homework. With this, we'll stop the lecture now. Let's go to attendance very quickly as usual. Start. And with this, we finish chapter 10. So the attendance now is open for you. Please take attendance and you can leave right away. Okay. We finished chapter 10. So today I will put the chapter 10 homework in the blackboard. It will be open and it will be due on Sunday. And next Monday we're going to have a quiz in chapter 4 and 10. So be ready for it, and I will send you all the information on the WhatsApp group.
Doctor.
Yes.
Doctor, next Monday.
Next Tuesday we have the midterm of math 002.
And Wednesday I have 001 midterm physical.
So it's
Yes,
very busy
Monday
next.
and Tuesday.
كيف
The midterms.
عندنا الميدتيرمز الاسبوع الجاي دكتور اكثر من
طيب
ميدتيرم.
ممتاز. طيب اسمحوا لي.
Next week very busy.
طيب we have to do it. متى نسويه؟ اللي بعده يوم الاربعاء.
الاسبوع اللي بعده.
ها؟ لا الاسبوع اللي بعده متاخر كثير لاني بعطيكم كويز.
الاسبوع اللي بعد يوم الخميس.
Wednesday.
الخميس يناسبهم؟
الخميس لا الخميس ما يناسبني انا لانه انا ما ابغى اسوي 3 اجزاء. نعم؟
الاربعاء كويس.
الاربعاء صباحا نفس التايم.
الاربعاء الجاي يعني ولا وش؟
طبعا الاربعاء الجاي.
احسن من الاثنين دكتور.
يعني ممكن اخر لكم الى الاربعاء، اما الاثنين او الاربعاء، اما غير كذا ما اقدر اخر.
خلاص الاربعاء.
الاربعاء دكتور احسن.
No problem. Then I can delay for you till Wednesday. Inshallah, same time, 8:30 صباحا. Okay?
Chapter 4 and 10, right?
Chapter 4 and 10. And the homework, no. The chapter 10 homework will be submitted by Sunday. And please don't tell me that you didn't do it. You have from today till Sunday. You can start doing it from today and finish it and get rid of it. Otherwise, don't tell me after Sunday, please reopen it. Okay. Yalla Shah. Shukran. And I will take a small break. Okay, let's start.